in this particular area. So we deem it fit as opportunity, that this should be an opportunity for us to reach a larger audience, and that's why we're having it in a kind of remote like this. So we will advise each and every one of us, the students, let's endeavor to keep our notes. We need to have notes for this class. So it's very, very important that we have notes. So don't look at it as an online class, and as a result of it, you just continue to watch. No, you should have a note. So I will also send my own note here. I will send it around. I will pass it across to us. So, but notwithstanding, you can also have your own note too. So, and then you make sure you revise. We can't actually master it until we solve a lot of problems from our own hand. So once you solve a lot of problems, it will assist you to be able to master those areas very well. That's just the major thing that you need in mathematics. You realize that when you continue to solve questions, then you realize that there will be changes. And that is the most important thing in mathematics. So like we said, this particular time is also like a 4 week. You know, we have just ended a 6 weeks program that we target further mathematics. We looked at some areas of further mathematics. So this time around, we want to look at some areas in trigonometry. Majorly, we want to cover all the aspects of trigonometry in mathematics, in general mathematics in WAEC. So it's a simple area that we need to at least it's like what do I call it? A simple area that you need to actually leverage on. And when you know trigonometry very well, it assists your mathematics. So I want us to be very serious with it. And one thing is that after the end of the 4 week, we also have a kind of evaluation, the test. Just like for this Saturday, we'll be having evaluation on the further maths that we did, 6 that we ended last week. So I want you to actually cooperate and let's be to time the class. So the major areas that we are going to look at, like I said, we want to cover the aspect of mathematics, trigonometry mathematics. So for today, we'll be looking at, okay, let me just give us the cap of everything we want to look at. We want to look at trigonometry. You know, when we say trigonometry, we mean measurement of, from the name, measurement of triangles. Measurement of triangles. But the meaning has actually been made to cover measurement of angles generally. So, but from the word trigonometry. So it's actually talking about measurement of triangles. So generally we call it measurement of angles. So that's what trigonometry means. So we are going to look at Pythagoras theorem. How do you actually, when we say triangles, we can have different type of triangles. We want to limit it to just having a right angle triangle and a non-right angle triangle. That's a way of looking at the types of triangles that we have. We can say that we have a right angled and a non-right angle triangle. So when you have a triangle, a right angle triangle, how can you measure those triangles? When you are measuring triangles, we are looking at measurement of either angles or the sides. So we have 3 angles, 3 sides. So if there is need for us to find any of those sides. So how do we do that? So that's what we are going to handle today. We want to look at Pythagoras theorem today. We want to look at trigonometric ratios, the SOHCAHTOA. We also so that's the area that we also look at special angles and complementary angles. So for this 4 week, for the second week, we are still going to look at other angles from 0 to 360 degrees. Then we also extend to angles of elevation, angle of depression, bearing and distances. Then before that, we will have also looked at the sine and the cosine rule. So now, so like I said, the major thing that I want to look at for today is want to look at the aspect of general introduction of, I think I've even made the general introduction. So we also look at Pythagoras theorem, we want to look at trigonometric ratio, we want to look at special angles and complementary angles. So those are the areas. So I've made some introduction earlier on about what do we call it? Trigonometry generally. So I've made that trigonometry generally, and I said that it's just measurement of angles. Now, when you are measuring angles, there are some things that you need to take note. Number one, you see, angles can be measured majorly in 3 different ways. We use 3 different types of measurement of angles. So when we say the different system that we use, we call one sexagesimal system, and that's the common one that we use. We use degrees. So we use degrees. You see, even in the degrees that we use too, the way we use it, we use decimal points with it. But part of what we also have is that when you measure in degrees, it means you are dividing the angle into 360 degrees. So when you are dividing the angle into 360 degrees, apart from that, now each degree too will also be subdivided. So when each degree is subdivided, they divide it into what? Into minutes. That's 60 minutes. Then each of the minutes too divided into what? Seconds, 60 seconds. So that's why there are some ways in which they use angle. Sometimes you see that they write angle as 23 degrees, maybe 2 minutes, and then it could be 3 seconds. They will put 1 mark here. So that's so this degree is actually, this one here is actually saying that 2/60 minutes. You get it? If you are trying to convert it to this, it's like 2/60 minutes. And then when you have this one like this, it's like 3/60 times 60. That's 3/3600. I won't dwell much on that because in most cases we are usually not concerned about it. But that is just the major ways of doing it. So when you want to convert to the standard we use. So by the time you do it like this, 2/60, 23 plus 2/60 plus 3/3600, you get your answer in form of decimal. It will be 23 point something. So that is what we mean by that. So another way in which we also find our angles is that we use centesimal, and that is talking about grads. That's why in our calculator you see DRG. In your calculator you see somewhere DRG. So this is for degree, this is for radian, and this is for grade. So that's another way of measuring angle. So we can talk about, so you may hear them saying grad. It's also a way of measuring. Another way of measuring angles is in what? In radian. In radian, we actually make use of it very well. When we that's the half there. We in calculus, our angles are usually measured in that particular form. So so that is okay. So okay, I think is being recorded already. Is live on YouTube. Okay, but let me. Okay, so is so that is that particular one. Okay, so that's so those are the different ways. But the one we are concerned with in mathematics is degrees. We are concerned with measurement in degree. Now, having explained that, so we go to the next aspect that we want to look at, and that is major thing is that we want to the objective we want to state whether a triangle is a right angle triangle or not. How do you know that? How do you know whether a triangle is a right angle or not? And let me just, I don't want to assume. What do we mean by a right angled triangle? So it's also something that you see, most those of those the key points, the key words there, we are supposed to break it down. I don't want to assume that you all know what you mean by a right angled triangle. But when we say a right angled triangle, I think I've explained what you mean by a triangle. Triangle. So anything of this nature, any shape with three sides is called triangle. So, but when we say a right angled triangle, a right angled triangle, so in such a case, we mean a triangle that has a right angle. A triangle with one of its angle that is what? Right angle. And when we say right angle, this is right angle. We use L shape. We use this to represent it. It means angle 90 degree. So any triangle that has one of its angle to be 90 degree, we call it what? A right angled triangle. So you need to take note of that. So we also need to state the ratio of the major trig ratio, trig functions. We are going to look at that one. We want to also look at how we can apply trigonometric functions in solving triangles and other related problems. Then as well, we want to establish relationship between trigonometric functions. So let's move from there. So Pythagoras theorem, you see, that is a way of establishing whether a triangle is right angled or not. Now, if I have, so there is a mathematician has been able to do that for us. That when you have a triangle, he now realized that the square, when they say the square, this is called in a right angle triangle, we call the longest side, the side facing the right angle. You know, this is right angle. I think I've explained that. We call it the hypotenuse. Hypotenuse. So that is what we call it, the hypotenuse. Now, in the remaining ones, the remaining two, they don't actually have a fixed name. If any angle, if an additional angle has not been given, you can see the only angle that has been given here is just 90 degrees. So we can't actually say whether this one is opposite or this one is adjacent in what? In Pythagoras theorem. Once an angle, additional angle has not been given, so we can't actually say which one is what? Hypotenuse, which one is opposite and which one is what? Adjacent. So as a result, in a Pythagoras theorem just states that the square of the what? Hypotenuse. The square of the hypotenuse squared, is equals to what? The sum of the squares of the two other sides. So if this side is called A and this side is called B, so it's equals to A squared plus B squared. So whereas in some places, textbook or whatsoever, you can still see it as hypotenuse square is equals to opposite square plus adjacent square. Well, no problem, but it's just that we can't actually say which one is opposite and which one is what adjacent if no additional angle has been given. So that's one of the things that we need to know. Now, actually, the meaning of this particular thing is that they realize that when they draw a square here, they realize that the square, when they counted square, I mean unit square. By the time I divide this into units, this is a square already. So I will also divide it into different squares. So if you see some textbook, you see it like that. Then you also have square here. So you have square like that. So they are saying that when they counted the squares here, it is equal to the addition of the squares here and this. So that is just what they are trying to say. So once you see any triangle, if you have a triangle that has what, maybe 3, 4, 5, and they want you to know whether it's what is a right angle triangle, what you just need to do is what, just look at them. Which one is the largest of the 3? The largest is what? Is 5. If you are able to establish that 5 square is equals to square of 3 plus square of 4, so it means such a triangle is what? Is a right angled triangle. So that is just what you mean by a right angle triangle, once you are able to establish it. So if this, look at this, 5 square is what? 25. 3 square is what? 9. 4 square is what? 16. So 9 plus 16, is it the same thing as 25? Yes. So it means a triangle with length 3, 4, and 5 is what? Is a right angled triangle. So as a result, the 3, 4, 5, 3, 4, and 5, we call them Pythagorean triplets. We call them Pythagorean triplets. So they are triplets, they go together. They may ask you a question that which of the following is a Pythagorean triplet? So 3, 4, 5 is a Pythagorean triplet. Why? Because when you find the square of 3, add it to the square of 4, it's going to give you the square of 5. There are so many numbers like that. I will give you some example of those numbers. All multiples of this we also give you Pythagorean triplet. For example, multiply everything here by 2. If I multiply 3 by 2, I'm going to have 6. I multiply 4 by 2, I'm going to have what? 8. I multiply 5 by 2, I'm going to have what? 10. So 6, 8, 10 is what? Is a Pythagorean triplet. Can somebody test that for us? Can somebody check that for us, whether it is actually true? If you have confirmed that, can you talk? Okay. All right, no problem. So, let's see. Let's check. If you check here now, 6 squared plus 8 squared. 6 squared is what? 36. 36 plus 8 squared is 64. You see that to give us 100. And 100 the same thing as 10 squared. So 6, 8, 10 is a Pythagorean triplet. If I also come here, I multiply this by 3. I'm going to have 3 times 3, 9. I have what? 3 times 4, 12. 3 times 5, 15. So 9, 12, 15 is also. So you can go and check that. Now, apart from this, we can also have some other ones. some other family. So it means all families of 3, 4, 5 are Pythagorean triplets. Other ones, we can also have family of 5, 12, and 13. 5, 12, and 13. Can we establish that? 5 squared plus 12 squared. 5 squared will give us 25. 25 plus 12 squared, 144. And that will give us 169, which is the same thing as 13 squared. So as a result, say 5, 12, 13 is also a Pythagorean triplet. Now, we may also have some other ones. So it means the family, if you continue to multiply this one too, if you continue to multiply, you can multiply 2 times 5, 10, 2 times 12, 24, 2 times 13, 26. You realize that 24, 10, 24, 26 is also what? A triplet. So once you see them, you know that these are Pythagorean triplets. So as a result, such a triangle will be what? A right-angled triangle. So you can also multiply by 3 and so on and so forth. Another family, quickly, that we can also have, you can just continue to test. So I will give you the assignment of finding out other basic family of Pythagorean triplet. I've identified 2 now. I've identified this. Family of 3, 4, 5 is a Pythagorean triplet. Family of what? 5, 12, 13 is a Pythagorean triplet. Let's also look, let me give you additional formula family. So you may now, as a kind of assignment or research, I can say that you should find out maybe 5 more families. 5 more families. So let me give you one more family. Apart from this, another family that we also have is the family of that's 8, 15, and 17. Let's test that. 8, 15, and 17. 8 squared plus 15 squared. 8 squared will give us what? 8 squared will give us 64. 15 squared will give us 225. By the time you add them together, it will give you 289. And 289 is same thing as what? 17 squared. So it means 8, 15, and 17 is also what? A family. Is also a family. Is a family of that. So I will give us an assignment on that. Find out more on the Pythagorean family. So let me give you to find out 5. I'm giving you a serious task. So it means you need to make serious, because you can see now 3, 4, 5. After 3, 4, 5, the next one is 5, 12, 13. You can see the way we move to 8, 15, 17. So which one will be the next? So I will appreciate if you can go and find out that particular one. So that is what you mean by Pythagorean theorem and Pythagorean triplets. So let's move to the next. So we may have more questions on this particular aspect. So those questions are just talking about as many questions as possible that we can meet. So I think I've given you enough. So let's just move because of time. So the next one, we want to look at trigonometric ratios. So what are the major trigonometric functions that we have? What are the ratios? And what are their ratios? Then how do we evaluate them? That is the sine, cosine, and the tangent. And then how do we apply the concept? of trigonometric functions in solving triangles. Now, in this case, what we just need to know. So we have been able to look at, let me just recap quickly. We have been able to look at how do you know that a triangle is what? Is a right angle triangle. And that is by using Pythagorean's theorem. So, and then which says that the square of the hypotenuse squared equals what? The sum of the squares of the two other sides. Sum of the squares of the two other sides. And we have seen so many examples on that one. So that is, now, you know, I told you we can't establish which one is opposite and which one is hypotenuse, adjacent. So, but in trig ratios now, trig ratios, in this case, we will be given a particular additional angle. Let this be the angle. So this place is still known as the what? The hypotenuse. So once this one has been identified as additional given angle or the target angle, then the next thing is what? To look at the angle, the side that is opposite to it, which is this place. Then you name it as your what? Opposite. So, and it means we have labeled two sides. So the third one will definitely be what? Adjacent. Sometimes the target angle or the given angle may not be that particular one that we have drawn. It could be here. It could be that it is this place that we have been given. So in such a case, if you have been given this place as the angle, so it means the side that is opposite to it will be called opposite. So this is still the hypotenuse, and in such a case, this will be the what? The adjacent. So we need to take note of that particular one. So we have the opposite, adjacent, and hypotenuse. So in this case now, when you have something of this nature, they have assisted us. We have the major trigonometry functions that we have are the sine, the cosine. The cosine, they said they call it complementary of a sine, the complement of a sine. So, and we also have what we call the tangent. So based on the opposite and the hypotenuse, together with the adjacent that we have, they have assisted us to see the value of each. For sine of an angle, we say that it is what? Opposite over, let me take us to that mnemonics that we have. We call it SOHCAHTOA. Everybody know it. Everybody knows what we mean by SOHCAHTOA. At least even if you don't know what we mean by it, you have heard of it before. So this S there is the one representing sine. The cosine, the C there is the one representing cosine, and the T there is the one representing tangent. So when we say sine of an angle theta is equals to the ratio of the opposite, this O over H, is the ratio of the opposite to the hypotenuse. So that is O over H. So I repeat it again. When we say sine of an angle is the ratio of the opposite side to that angle to the hypotenuse. So which you say that opposite over hypotenuse, opposite over hypotenuse. So once you remember your SO, the O there is standing for opposite and the H is standing for what? Hypotenuse. So that is one thing that we need to know. The C, I've told you the C means cosine. So we shorten it to be cos theta. And it is equals to what? The adjacent. The ratio of the adjacent side to the what? Hypotenuse. The ratio of the adjacent side to the hypotenuse. So we say adjacent over hypotenuse. So that is what we mean by what? The cosine, the cos theta. Then we also have what we call the tan theta. So which is what? The ratio of the, you can see it is twa, the ratio of the opposite to the adjacent. Opposite to the what? Adjacent. So those are some of the facts that we need to take note there. And then likewise, we also realize that by the time you look at these three things, three ratios, so we call their trigonometric ratios. So if you look at those three ratios, you realize that they are also related. So as a result, we say that what? Our tan theta is the ratio of the sine to what? The cosine. Because we realize that when you multiply opposite over hypotenuse by adjacent over hypotenuse, or you divide it, so you realize that we are going to have what? Opposite over adjacent. If you divide opposite over hypotenuse by adjacent over hypotenuse, you are going to have opposite over adjacent. So that's why we say that what? In such a case, the two so tan theta equals what? The ratio of the sine to the cosine. So I hope you are adequately following. So now, having done that, having established that, another thing that we now need to look at is how do we evaluate our sine? How do we evaluate sine? Well, one of those things, if you have your mathematics textbooks with you, you realize that at the back we usually have okay, I think I didn't download that. Okay, I was trying to download that before. So but notwithstanding, let me just give us how it looked like. We have our table. So we said, how do we evaluate it? It's either we use our 4-figure table to evaluate it, or we use what? The calculator. Either you use 4-figure table to evaluate it, or you use calculator. Now, if you are using 4-figure table, it's something that you need to know. You need to know how to use 4-figure table in solving this. Our 4-figure table has been, I explained earlier that we have majorly 3 basic ways of measuring our angles. So I mentioned the degrees, the radian, and the grade. So our 4-figure table has also been done in such a way that to reflect for degrees and radian. I'm very sure of those ones. I don't think I've come across a grade in the 4-figure table. So okay, it is not clear. Don't worry, don't worry, you get what I'm trying to say. So I've explained that earlier, that we have 3 different ways of measuring angles: degree, the radian, and grade. But don't worry, for this particular class, what we are after is degree. Okay. I want to believe that I'm still audible. You can just check. Such a person may, somebody said they can't hear. You just need to check your speaker. I can see that other people can hear me. So I think I can observe that. So degree, radian, but what we are after now is what? Degree. In our 4-figure table, you see degree there, although you also see radian. So for example, if you have that of sine, sign of angles in degree. They will write it there, sign of angles in degree. Now they will start, if you look at it very well, you realize that they start this one from 0, 0. And they have 0.1 here, 0.2, 0.3, up to 0.9. They divide it like this. They also have 1, 2, 3, 4, up to 9. And this 0, 0 also goes down to 89. So it means the last number there is 89.99. 89.99. So this is 0, 0.1. That is what you get. We are going to find here. 0, 0.1. If you are coming here, you get 0, 0.11. So that is the way our four-figure table has been designed. So for example, if I need to go to my four-figure table to check the value of sine 30.0. Okay, sorry. I think this one should start from 0.0. Yeah, thank you. It starts from 0.0. After 0.0 is 0.1. So if I need to check 30.0, I will just check 30 under 0, which will be here. So it is going to give me sine 30 will be equals to, or 30.0 will be equals to what? I think you are going to see 0.5000 there. So you may also want to check 30.2 or 30.1. It means the next one there. 30.2 is the next one. 30.3 is the next one. Now, sometimes you want to check something like 30.45. How do we do that? So it means we just go to 30 under 4. Whatever you have here is what you write down. Sorry, I don't have the exact value for that now here. So if you, let's assume that in that case, you get 0.50, maybe 0.6. And you are looking for 30.45. You now go to what? You go outside under 5. You know, 5 will be somewhere here. You trace it down. You are going to see up here, you are going to see add differences. So the difference that you have here, that is what you are going to what? Add to it. If the difference, for example, under 4, if the difference is 3, you now add the 3 to this. So it means at the end of the day, by the time you add, you are going to have 0.5009. So that will be the value of sine 30.45. So the same way is the same way sine has been made is the same way tan of theta, tan is also made in the same way. But the only difference is cosine, because cosine, the difference in cosine is that cosine, instead of add difference that you have here, cosine we put that what? Subtract difference. So like this difference that you got, if it were to be in cosine, you are going to subtract. It means it will give you 0.5003. You subtract. So please, it is very, very essential that we know how to use the four-figure table. At least I've done an exam before. I think that was back then in, yeah, for those doing Cowbellpedia exam. Yes, you are not allowed. I think till this moment, you are not allowed to use calculator. And you can be given questions like being there. So how do you want to solve such? So you can use your four-figure table to do that. So, and that is the essence of logarithm that you have been taught. How do you multiply with four-figure table? You can use your logarithm. How do you divide? How do you find the square root? How, and so on like that. So please, there's need for us to know how to use four-figure table. You also go for, in fact, in some exams, you want to do serious calculation. You see, you have square root, you have inverse, reciprocal, everything you have in your four-figure table. So I will advise you, learn how to use four-figure table. If you have any challenge, you can always contact me. I will put you through. So those are some of the, so you can also use your calculator. Calculator is very, very easy to use. Just punch. You don't need to disturb yourself. Sine of what? 30.45. So just press it like that. You get your straight answer. So the next thing is, how do we now apply the concept of trigonometric functions in solving triangles? So we are going to look at that one now. So for example, we have some questions here. So given that sine x equals 3/5, where our x is between 0 degree and 90 degree. Yes, as a student of mathematics, you need to know how to pronounce this. It's very bad of us to call this one 0 degree less than or equals to x less than or equals to 90 degree. As a student, as a learned, you are not expected to call the 0 degree is less than or equals to x less than or equals to, no. So you come from the unknown here. You are describing x. So you come to x first. Say that what? X is greater than or equal to 0, but less than or equal to 90 degree. So I will say it again. X is greater. You know, when you were in primary school, you were taught with your left hand that your left hand means what? Less than. And your right hand means what? Greater than. So you can see that you have moved now. This is a compound inequality. So how do you pronounce the compound expressions in compound inequality? So you can see if I say 5 is less than 7. Just like if you can move a car forward, you should be able to move it backward. 5 is less than 7. What does that mean? It means 7 is greater than 5. If I'm reading like this, I'll say 5 is greater than 7. But if I'm coming back, I will say that was 7 is greater than 5. So as a result, we are picking this first. S is greater than or equals to 0, but less than or equals to 90. So what they are just telling us with that is that we are still within acute angle. In next week, by next week, we are going to at least take us through how we can deal with angles that are beyond 90 degrees, that are more than 90 degrees. You can see that calculate the four-figure table that I've also just explained too is limited to 0 to what? 89.99. So if you are given angles that are more than 90 degrees, how do you use calculator to find it? We are still going to do those ones by next week, God's willing. So now going back to this question, it says sine x is given as 3/5. Find the value of 5 cos x minus 4 tan x. Now the approach that we can use as a student of mathematics, see, those offering further maths, they may say there is also another way they can do that. But for mathematics, we may not be able to use that particular approach because we did not treat such concepts. So solution to this now, how do we solve it? So we have been given sine x as what? 3/5 from our mnemonics. So anytime you want to solve problems on this, you have to state the mnemonic. It's better you state it. Then you now look at what have you been given. Now, from the mnemonic, sine represents opposite over hypotenuse. So it means it's representing something of this nature, opposite over hypotenuse. So it means we can represent, we can say O is not actually 3, but the fraction of the two of O to H, or the ratio of O to H is 3 to 5. So as a result, we can draw our triangle. We can draw our triangle. So once you draw your triangle, from there, we can now say that what? Let's assume that this is the X that has been given. If this is the X that has been given, then we can now label it. That's the hypotenuse. So the hypotenuse here has been given as 5. Then because this one is the angle, given angle, so this is the opposite to it. And the opposite has been given as what? 3. From our Pythagorean triplet, what is this? You see, in mathematics, not every time, yes, I'm an examiner for further mathematics. And so if I say some things, I say it with the evidence. For example, in this case now, if you don't tell us how you have got, is that Bilal Zakaria, or who is that? I don't want to mention, I don't want to say anything about that person drawing arrow. So please respect yourself. Okay, so let me move on. So 3, 5. So in this case now, in this case, we can now find this. From our Pythagorean triplet, we can find this to be 4. In fact, you can't be, you see, anytime question of this nature has been given, the answer to this, if they need to mark it at all, they will give it as a B mark. It's a bonus mark. They don't want to know which method you have used to get it. So from our Pythagorean triplet, I've got this one to be what? 4. Because I know that if the hypotenuse is 5 and I have this one as 3, then this one must be what? Must be 4. So I've got that, and that's the adjacent. So what did they ask me to find? They asked me to find 5 cos x minus 4 tan x. It means I need the value of what? I need the value of cos x. Cos x should be what? From my SOHCAHTOA, you come back to this. It should be adjacent over hypotenuse. What's the adjacent from the diagram? The adjacent is 4. What's the hypotenuse from the diagram? It is 5. So it means the value of cos x is what? 4 over 5. I also need the value of tan. So tan x. From my mnemonics, tan is what? The ratio of what? Opposite. Opposite to what? Adjacent. So what's the opposite from here? The opposite is 3. What's the adjacent? The adjacent is what? 4. So that's 3 over 4. So from there, I've got expression for that. So I can now go back to the expression. I have 5 cos x minus 4 tan x. It will give me what? 5 multiplied by cos x. That's 4 over 5. Minus 4 multiplied by tan x. Tan x is what? That's 3 over 4. So when I multiply 5, we cancel 5 here. 4, we cancel 4. I'm left with what? 4. 5 here. Cancel the 5 here. So I have what? 4. The same thing happens here. I have 3. So the answer is 1. So it means the value of 5 cos x minus 4 tan x is equals to 1. So that is what we mean by that. Now, I think we have solved that question. So the second question is also similar. So how do we do that kind of question? So from what we have tan x. Tan x has been given as what? 3 over 4. So you go back to the mnemonics. You go back to the mnemonics. The mnemonics for tan is what? Toi. That's what? Opposite over adjacent. So what is our opposite? So it means we can actually say that what? Our opposite. You see, there's a particular question I'm going to give to you as a kind of just for you to look at that question, and if you can solve it, I'm going to check. I think, yeah, I will look for that question. I will give you. I think I have it. So that question here, the TV here does not actually mean that the opposite is TV. But if the opposite is 3, it's just saying that the adjacent is what? 4. That the ratio. You see, another thing that it could be that the opposite is, because let me multiply both sides by 2 now. It means that we have 2 times 3 is 6 over 2 times 4, 8. So it could be that opposite is 6 and adjacent is 8. Do you get that? But if it is like that too, so it will assist us in getting the other side. Just like we have mentioned, you don't forget, when we mentioned 3, 4, 5, I said all their multiples will also work. So if this is 2 times 3 is 6, 2 times 4, 8, 2 times 5, 10. So you can see if 6 and 8, the third one will be what? 10. If it is 3 and 4, the third one will be what? 5. You can see it's also multiple of it. So, and when you are dividing, it will still be the same thing. So in this case, you just assume that our opposite is 3 and our adjacent is 4. So you draw the triangle as I have done the other time too. So let this place be what? X. Then opposite is 3. This is what? 4. So by Pythagorean triplet, this place must be what? 5. I don't need to solve it out. Once I know my Pythagorean triplet very well, if I'm very sure of it, I just need to go on. So, so in that case, you see, the reason for that, some may be looking at why do you have to do it like that? Why not solve? You see, sometimes you don't need to use, sometimes some people, when they solve some questions that you can just solve with 2, 3 lines, they end up solving with a page, 2 pages. You see, things like that, they are what discourage students from learning mathematics. So solution of this one is 4 pages. Lie. So there are always simple or simpler approaches to those kind of problems. So in this case now, I don't need to continue to now say I want to go and apply Pythagoras theorem before I get my 5. That's not the major thing that they have asked me to do. You can see the question, the real question is here. So this one since there is what we call Pythagorean triplet, something has established that. So they don't need us to go and be finding something that is not lost. So just put it there. Once you are very sure of it. If you are not sure of it, you need to work it out then. So I haven't done that. So we need the value of cos and we need the value of sine from this question asked. So how do we get our sine, our cos? So cos x, from the mnemonics, it is adjacent over hypotenuse. So what is our adjacent? The adjacent, if you label it, this is the hypotenuse. The one that is opposite to x is called opposite. And the other one is called adjacent. So A is what? 4. And the H is what? 5. So for sine x, sine is what? Opposite over hypotenuse. So what is our opposite? Our opposite is 3. And the what? The hypotenuse. Hypotenuse is what? Is 5. So as a result, I want to look at the expression cos x over 2 sine x. So cos x is what? 4 over 5 divided by 2 into bracket 3 over 5. And that will give us 4 over 5 divided by, I can use this kind of division. 2 times 3 is 6 over 5. Please know that when you have expression of this nature, these 2 will only multiply the numerator. The 2 will only multiply the numerator, not both. So take note of that. So we have 4 over 5 multiplied by 5 over 6. So 5 cancel 5, we have 4 over 6. And 4 over 6, when you break it down, 2 can go in both. 2 in 4, 2. 2 in 6 is 3. So that would be what? 2 over 3. So it means that expression cos x over 2 sine x. See, it's always good to conclude. Is equals to what? 2 over 3. So that's our conclusion. So that's the value. They want us to evaluate and to give us 2 over 3. So that is how we can do that. Well, there's not much time on our side. So let's move on. I want to believe that it is clearly understood. You can just screenshot and let's move on. So special angles is what we want to look at. Special angles. Special angles. So what do we mean by special angles? There are some angles that we realize that they are indeed special. So some of those angles are angle 0 degree, angle 30 degree, angle 45 degrees, angle 60 degrees, and angle 90 degrees. So one thing there is that we realize that since we have looked at some angles now, something about triangles. Now let's assume that we have an equilateral triangle. Now, you know, I mentioned that triangles can be divided into right angle or non-right angle. That's on one side. Another way in which you can classify triangle is based on their sides. You see, right angle and non-right angle has been classified based on the angles. If you are doing your classification based on what? On the sides, then we say we have scalene triangle. We say we have what? Isosceles triangle. And we say we have what? Equilateral triangle. Now let's assume that we are given an equilateral triangle. Equilateral triangle are triangles whose angles are equal. They are equal. The 3 angles are equal. And as a result, the 3 sides are equal. And in a triangle, the sum of angles is what? 180 degrees, sorry. It is 180 degrees. So if you have 180 degrees and you want to share it in between the 3 angles, definitely it will give us, each of them will be 60 degrees. So it means this is 60, this is 60, and this is 60. And let's assume that each side, since they are equal, let's assume that they are of side 2 units, length 2 units, length 2 units. So if you have that, then let me divide this triangle. If I divide, it means I'm dividing, I'm bisecting this angle 60. This one will give me angle 30 degree. This one will give me angle 30 degree. And this one will definitely be 90 degree. So based on that, I will have got something of this nature. This is 90 degree. And this is 2 units. Since I've divided, I've bisected this, it means this will be 1, 1. So this is 1. So we need to find this. You can't use triplet. There's no triplet that combine 1 and 2 together. Exactly. But from Pythagoras theorem, you can just say that what? The square of the hypotenuse, 2 squared, equals the square of the two other sides, sum of the squares of the two other sides. So s squared plus 1 squared. So this 2 squared, give us 4. 1, bring it here, you have minus 1 equals to s squared. From there, we can say that s squared is equals to 3. And then x will be equals to what? Plus or minus the square root of 3. But it is the plus that we need now. But it's actually plus or minus the square root of 3. So it's the plus that we need now, because length can never be negative. So plus 3. So from what we have learned, we said this one is 30 degrees. And this is what? 60 degrees from the diagram up. Now, we realize that we can easily from here, we can easily find the value of some of these special angles. So sine 30, we can easily get it. Cos 30, we can easily get it from here. Now, let me start from 30 degrees. Let me start from 30 degrees. You see, 30 degrees and 60 degrees we can get it from here. So let me start from 30 degrees. Let me redraw the triangle. If I redraw the triangle, and then I'm only interested in what? Angle 30 degrees. So I don't need to indicate angle 60 degrees. So with that, this is still the hypotenuse, which is 2. The length is 2 units. And this will now be the opposite, because that's the opposite to that particular angle. And in such a case, the what? It is 1 unit. Then this that I've got to be square root of 3 will be the what? Adjacent. The third side, adjacent. So from there, I can find, don't forget, my mnemonics is what? So, ka, tua. So meaning that my sine theta, sine of 30 degrees, will be equals to what? Opposite over hypotenuse. What is my opposite? 1 over hypotenuse, 2. So 1 over 2, which is same as 0.5. If you press your calculator, you realize that the value for sine 30 degrees is what? 1 over 2. So you can see that we have been able to establish that from here. Then let's go to cos. Cos 30 degrees will be equals to what? Cos 30 degrees will now be equals to what? That's adjacent over hypotenuse. What's our adjacent here? That's square root of 3 divided by what? Hypotenuse. That's 2. So if you press your calculator, cos 30 degrees will give you root 3 over 2. Or for those that don't have such a calculator, you are going to arrive at 0.8660 or 8661. So that's around that figure that you get. So then on this one, we have tan 30 degrees will be equals to what? Tan 30. Tan is what? 2. Opposite over adjacent. What's the opposite? Opposite is 1. Adjacent is what? Square root of 3. So for those that don't have such a calculator, it will give you 0.571 or so. So that is that. Now moving to angle 60 degrees. Moving to angle 60 degrees. You know which one is 60? So it is this one that is 60 degrees. I still have this place as 2. I still have this place as square root of 3. And I still have what this place as 1. But the naming will change. This is still the hypotenuse because it's the longest side and it's the side facing angle 90 degrees. That's how we know that it's the longest side. Now, the next one, how do you get your opposite? Don't forget, I've said opposite is opposite to the angle. So this is our opposite. And this is what? Our adjacent. So from there, I can get my sine 60 degrees. to be equals to what? Opposite over hypotenuse. Our opposite is square root of 3 over hypotenuse, which is 2. Likewise, we can get cos 60 degree as what? Adjacent, k over hypotenuse. What's adjacent? 1 over what? 2. And likewise, we can get the value of what? The value of that's tan 60 degree to be equals to what? Opposite over adjacent. What's the opposite? Square root of 3 over what? 1. So that is how, in simple term, how we can what? Use such to find the value of our special angle. So we refer to them as special angle. Another one is that we can also get that of 45. We can also get that of 45. But to get that of 45, we are not using the same triangle. We are using another kind of triangle. So in this case, now we are combining the two classifications I've mentioned earlier. We are combining both angle classification and side classification. So in such a case, we say that is what? Isosceles right angled. So how? What do I mean by that? If you have an isosceles triangle which is also right angled, it's right angle and it's isosceles because this and this are equal. So in such a case, you know, both of them will be 45, 45 because the sum of angles should be what? 180 degree. And since this one has taken 90, you divide the remaining 90 between the two because they said they are equal. Once this side and this side are equal, their base angle will be equal. The base angle they are trying to say is that you realize that the two sides that are equal, they are meeting at this point. So when you trace that, the line down where they form angle with the third side is what will be equal. So this place will be 45 and this place will be 45. And what we actually use, the isosceles triangle, is not just isosceles. And the length is also unit, 1 unit, 1 unit. So using Pythagoras theorem here, you realize that what? We want to find x. What do? X squared equals 1 squared plus 1 squared. 1 squared is 1, 1 squared is 1, that's 2. So x squared, x is equals to square root of 2. So it means this is what? Square root of 2. So having established that, we can say that what? Sine 45. Let's assume that we can't even see this angle. This is the only angle we can see. So definitely this one will be opposite. And this will be what? Adjacent. I haven't known before that this is what? Hypotenuse. So from there we can say that sine 45 degree will be equals to what? Sine 45. Sine. Just go back to opposite over hypotenuse. That's 1 over root 2. Cos 45. Also look at it. It will be what? Adjacent over hypotenuse. It's still 1 over root 2. And lastly, tan 45 will be equals to what? Opposite over adjacent. That's 1 over 1, which is same thing as 1. So having established, so we can see that we have been able to look at 30 degrees. We have been able to look at 45. We have been able to look at 90 degrees. So those are the major special angles. So for 0 and 90, we are still going to see how we can get those ones out. Now, having known this, do you observe anything in your mind? You should have, from what you can see, the values that you can see. You can see 1 over 2. You can see root 3 over 2. You can see 1 over root 3. You can see root 3 over 2. We can see 1 over 2. We can see root 3 over 1. We can see 1 over root 2, 1 over root 2, and 1. Don't you think they have relationship? They are related. Don't you think? Can I have anybody to say 1 or 2 things? Did you see any relationship between them? Can we use that to make any judgment? Like I have one of my teacher in artificial intelligence here. In person of Mr. Ahmed Olanwaju there. You know, one of those things they taught us in the artificial intelligence is that they try to establish relationship. They study pattern. They actually study pattern. So in artificial intelligence, and that is some of those things that you said. Okay, you are saying something.
Sin 30 equals sin 45.
Tan 30 equals sin 45. Are you sure? Tan 30 is 1 over root 3, and sin 45 is 1 over root 2.
This sin 30.
You said? Okay, Abiba.
Cos 30 equals sin. Cos 30
Okay,
equals
yeah.
sin 60.
Okay, Abiba is telling us that sin 30 equals cos 60. Thank you. Yes. Then cos 30.
Cos 30 equals sin 60.
Sin 60. Yes. Any other one? Any other one?
Sin 45 equals to cos 45.
Thank you. Sin 45 equals what? Cos 45.
Cos
Good.
45.
Very good. So thank you. Thank you for that brilliant observation. Now, actually, you also realize that there are some, though these ones are direct, there are some that are not direct. You know, I told you sin 30 over cos 30 will give us tan 30. You can try that. You realize that it will work. Sin 60 over cos 60, you realize that it will give you this, tan 60. So sin 45 over cos 45, realize that it will give you tan 45. So you can try that one out. Now, having seen that we have established relationship here, can you study the pattern there? You have to study the pattern so that subsequently, why are they equal? So that subsequently we want to use it. When we want to use it subsequently to assist you, once you study the pattern there. So that if I have something like maybe sine 15 degree now, what will it be equal to? You can see that sine is being equated to what? Cos. So if I have sine 15 now, it will be equal to cos what?
Cos 30.
Cos 30. Why? Because what?
30 times 2 is 60.
Okay, 30 times 2 is 60. Look at this one. This is 30 times 2 give us this, I'll be 60. And what of 45? Is 45 times 2 equals to 45?
Why you say?
So it means you did not get the pattern well. That's not the pattern. That's not the pattern. Yeah, who is telling us sine 15 degree will be equals to cos what? Can somebody tell us that pattern? Yes, Sanusi Aliamin. Are you saying something? Cos 45. 45, Abi?
Yes, sir.
Why do you say 45? Okay. Oh yeah. Don't let me help you. Why do you say 45? Because they added 30 to this one to give you 60. Abi? So you should add 30 to this one to give 45. No, that pattern does not work. Does that pattern work for 45 and 45? Oh,
No, sir.
yeah, now you should have seen something there. So that one too is wrong. Yes. Who want to help us at least look at that pattern, discover a pattern there. There's a pattern there. And once you get the pattern, it will assist anything at all you want to get. Anything you want to find, it will be very easy for you to get.
So,
Okay.
so because of sine 0 starts from 0.000 and cos 0
Okay.
starts from 1.000. So
Okay.
therefore, sine 15 will be
Okay.
equals to so sine 15 will be equals to cos 75.
Okay. Sine 15 will be equals to cos 75. Okay. Well, you have made a very good point there. That sine 0 is from 1, is from 0. Okay. And then cos 0 is from what? Is from 1. Okay. Now, and so can you now use that? What you have done, can you use it to explain what you have on the board? Okay, you have tried. That's a very good one. So let me tell you that.
Sine 15. Sine 15. Sine 15.
You have got it. It's
Sine
75. The
15.
answer is 75. The answer is 75. But let me tell you, let me give you a very straight, a direct this thing. It may not be easy the way you have said it to get. Now, what you observe is that the two angles, when you add them up, it must give you 90 degrees. 30 plus 60, 90. 30 plus 60, 90. 45 plus 45, 90. Is that clear? So before sine can be equated to cos, it means that what? The two angles must be complementary. What do you mean by complementary? They equate to 90 degrees. The sum of the two angles will give you 90 degrees. So sine and cosine of angles that are complementary, they are equal. So sine 15, I will look for what will I add to 15 to give me 90, and that is 75. So we say sine 15 degree equals cos 75 degrees. I may pick sine 18. Okay, no, let me pick 25. Sine 25, it means it must be equals to what? Cos, what do I add to 25 to make it 90?
65.
That's 65. That's 65.
That's 65.
So, and so on and so forth. So that is what we mean by complementary angles. So that is what we can establish here, is that before sine can be equated to what? Cosine. Once you see they are equating sine and cosine together, then something about what complementary angle should come to your mind. Exactly. So I think this is just the last concept we are looking at today. But don't let us go like that. Let's just conclude it with some examples. So I have some examples here for us. You want us to solve sine x equals to cos 25. Sine x equals to cos 25. You see, a simple approach that you can just give to it is that anytime you see such a question, solution for the first one, sine x equals cos 25. So since this is sine is being equated to cos, I've told you they can't just equate sine and cosine except that what the two angles add up to give us 90. Just come and say 9x plus 25 equals to 90 degrees. So what will you add to 25 to give you 90? I think, okay, we have even
55.
done it. That's 5. So the next one, sine of x plus 10 equals cos of x minus 20. So you don't need to disturb yourself. I've told you, once sine is equated to cos, it means the two angles there must be complementary. It means they add up to 90 degrees. Oh yeah, add them up. What are the two angles that you have? We have angle x plus 10 and what? Angle x minus 20. Those are the two angles that you have. So add them up to give you 90 degrees. The addition must give you 90 degrees. It's a must. So by the time you collect like terms, you have 2x. 10 minus 20 will give us minus 10 equals to 90 degrees. So 2x equals to what? 90 plus 10, that's 100. So x will be equals
X
to
is equal
50.
to 50.
Yeah. So it means x must be equals to what? 50. So who want to do number 3 for us?
Sine
3x plus cos 2x.
Sammy,
Okay. Oh yeah. Go ahead.
sin 3x cos 2x.
Okay. Sin 2x equals to cos 2x.
So that means you add your 3x plus 2x
Very good. You add 3x plus 2x.
plus 2x equals to 90 degrees.
Very good. Equals to 90 degrees. So
That would be
what?
5x. 5x equals to 90.
Yeah. So it means x is
Then
what?
divide both sides. X will
By
be 90 divided by 5, which will
yeah,
be
that is 18.
18 degrees. 18 degrees.
Yeah. So x equals 18 degrees. Now the last question there. Sin 25, that's another way of asking such a question. Sin 25 over cos 65 plus cos 5 over sin 85.
90 minus 25. 65 over 25 is
Okay. Any idea?
So yes.
Okay, oh yeah. Please go ahead.
Because your sin 25 and your cos 65 plus sin plus your cos 5 over sin 85 is already given.
Okay.
So you can just put your equals to 90 degree and you add normally.
Equals to 90 degrees and add normally. Yeah, how do you do that?
Then it will give you
Okay, I'm listening.
then it will give you 25 over 65 plus 5 over 85 equals to 90 degrees.
No. That's not correct. Can anybody share another idea with us? Yes, any other idea? You see, what we are trying to say is that what do you observe? 25 and 65. You can see that the top here. Okay, let me write the question number 4. we have sine 25 over cos 65 plus cos 5 over what? Sine 85. Now, if you observe, you realize that sine 25 over cos, yes, they are opposite, and this is sine and cos. And you realize that this 25 and 65, they add up to give you what? 90 degrees. And don't forget, what it means is that sine 25 is equals to cos 65. Do you agree with me? Do you agree with me that sine 25 equals to cos 65?
Yes.
You agree with me, Abby? Sine 25 equals to
Yes,
cos
sir.
65. Because
Yes,
by
sir.
then you add 25 and 65, it will give us what? 90 degrees. Now, when you have two things that are equal and they are what? Being divided, 5 over 5, what will it give us?
1.
So 1.
1. 20 over 20, what will it give us?
1.
1. So
One.
when they are equal, so you can see that sine 25 is equals to cos 65. So it means they are equal. Check for this one too. We have cos 5 equals to sine 85. You can see that they are opposite signs, cos and sine. They are opposite functions. So if you add 5 to 85, will it give you 90 degrees?
Yes.
Yes.
So it means they
Yes.
are also equal. So it means they are also equal. And when the numerator and denominator are equal, such a fraction will give us 1. So as a result, the whole of this is 1,
1 plus
and the
1
whole of this is also what? 1.
1.
1 plus 1 is what?
equal to
2.
Okay.
Do you get that?
Yes,
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 sir.
sir.
Okay. So these are your own questions. Your own questions. So this is like assignment, question 1 and 2. The assignment. Okay, this under quiz question. You can also do this as assignment. Although I will still send some other questions to you. But can we quickly use this question 2 as a quiz? So given that the length of a triangle are given in the form ABC, which of the triangles with the following dimension is a triangle? Abi? Yeah. So which one is a triangle? Is a right angle triangle?
A.
First one.
The first one, sir.
The first one.
Option A.
Okay. I think the question is meant to say that which is not a right angled triangle. Yes. That's what the question is meant to say. Which one is not a right angled triangle? Can you answer the question in 30 seconds or 10 seconds? You know, when you go for mathematics competition, quiz questions are
Option T.
usually given option.
So the answer is C.
The answer is C. The answer is D. Which one is the answer?
E.
Okay, you all have said that this is a right angle triangle because this is a triplet. You all accepted this too. We have done that. So, but we didn't mention anything about this. Oh yeah, and we check that 7 squared. That's why you have to know it. Once you know it, it will not take you up to 5 seconds to solve this.
C.
See, let's try. 7 squared plus 24 squared. What is 7 squared?
Is D.
9.
Okay, 49. What is 24
7
squared?
square is 29. 4 square is
Don't worry,
580.
let's confirm. Let's confirm. This one is 576, Abi.
Yes.
So when you add
That is
57,
625.
Just 225. So the answer is D.
That is D.
so the assignment I gave you earlier, you can't include this one again. We have found out this one. So I said you should look for 5 more. So look for 5 more. 5 more Pythagorean triplet apart from the one we discussed in the class. So D, let's try D. Let's check D. 9 squared plus 20 squared. 9 squared will give us 81. 20 squared will give us what? 400. That will be what? 481. And then it is not the same thing as 21 square. Because 21 square should give us what? 21 square, that's 444. Am I right? 441. This is 1, this is 2, this is 2, this is 4. Yeah, 441. So which is not the same thing as 481. So okay, the second quiz, have you got the answer now? The first quiz complete, the first quiz question. Sine 5x minus 28 equals cos 3x minus 50. I've also put it as a quiz question.
The answer.
Okay.
So the answer is 21.
The answer is 21. Okay, somebody said 21. Any other person? 21 degrees. We are waiting for others. Who said 21?
So I did.
Okay, what's the name? What's your name here?
Alamin.
Okay, Aliamin. Okay. For those who are not yet in our group, in the group we created for A2C Learning Circle, so I've sent the link to the group on the chat box. So just look at it and join. I will send this particular note to that class. And I will send you the link to this video. In case you want to try to revise on it. Okay.
Yes,
So
the
is there
answer
another person giving us an answer apart from Aliami?
the answer is 21, sir.
21. Okay.
Yes.
All right. Let's do it together. So it is very simple to do. We have said once you have anything of that nature, sine 5x minus 28 equals cos 3x minus 50. So what do? Just add them together. 5x minus 28 plus 3x minus 50 must give you what? Must give you 90 degrees. So 5x plus 3x, that's 8x minus 78 equals to 90 degrees. So 8x equals, when you add, you have 168. So divide both sides by 8. So x equals 21 degrees. That's absolutely correct. So absolutely correct. So that's the last question we are considering. So like I said, you can just, so I've sent the link to the group again for those that are not with us. So, or if you are not
Well
interested in
done.
joining the group, once you do your assignment, you can just,
Yes, well done.
you can send,
Two of our
you
parcel.
can send it to me on my WhatsApp group, on
No,
WhatsApp
she's very sweet.
page, 08093
Ben,
18998.
I don't want
In case you are not joining the group,
any
so
giver.
you can always send your assignment. I always appreciate that assignments are done and submitted to time.
Oh,
So when you do your assignment, you can always send it to me. That's my number. So the same thing as my WhatsApp number. So you can always, yes, let me open the floor for you to give any comment, any question, any reaction before we end today's class. Yes.